Good morning, everyone. Welcome to this CMCC seminar. I hope you can hear me, and you can chat yes if my voice is clear to you. I'm very glad to introduce this seminar, which that will be presented by Nicita. I think that most of you remember and know Lea because she worked before at the Fondazione Enrico Mattei for a long while. Since we were there were a lot of us there, but now Lea is conducting a Marie Curie fellowship. And this seminar is the presentation of one part of her work within the Marie Curie development. That let me also recall that her Marie Curie is, I mean, she spent her period abroad in these particularly difficult times under the supervision of Professor Mendelssohn. Now she's back here in Italy, and the topic of her work is on the assessment of the role of agrobiodiversity in the Mediterranean region, but also in a broader sense in the assessment in determining the value of let's say farmland activity, or the value of agricultural production. Of course, the focus is to understand how climate change could impact this value, and also her work is based on a, let's say, two-step investigation phase. One which is more econometrically oriented in order to estimate the value of agrobiodiversity, and the next that should be starting in a while, but I would say the next future is to develop also a macroeconomic assessment. So after having determined and estimated the role of agrobiodiversity, and also possibly having performed some projection, then we are going to use, and this is why also the host institution is CMCC, we're going to apply computable general equilibrium models to move towards the quantification of higher order effect and impact of this. But so with that, I will leave the floor to Lea. And usually, more or less, we have 35-40 minutes for the presentation, and then the floor will be open to questions by the audience. Okay. We can use directly, I mean, either the chat, but also, since we are not hundreds, we can also use the voice. So you can after the presentation briefly tell who you are, and then ask a question directly to Lea. So Lea, the floor is yours.
Thank you, Francesco. So as Francesco was telling, the work I'm going to present today has been developed during the first year of the CRAS project, and at the Yale School of the Environment, and under the supervision of Professor Mendelssohn. The overall goal of the CRAS project is to assess whether agrobiodiversity reduce the impact or increase the resilience of agricultural sectors against climate change. Okay, so this is the infographic of the project, and as already Francesco told, the project has two main parts. parts. The first part is the Ricardian analysis, an econometric analysis, and is devoted to assess the impact of agrobiodiversity on land value, and also accounting for climate change. In fact, there are temperature and precipitation in the econometric model. The results of the first part will be the input for the second part, that is the integrated assessment analysis. And agricultural sector of the CGM model will be modified to account for agrobiodiversity and to assess whether, for example, policy for biodiversity conservation will have also an impact in reducing climate change damages. Of course, the results of the model will be then disclosed to several actors. So, how we can link biodiversity to productivity and resilience. So if we consider the agroecology literature, agrobiodiversity or biodiversity in general affects ecosystem functioning, and ecosystem functioning, of course, will determine the provision of ecosystem services. So if we consider what is in most of the contribution of agroecology, agrobiodiversity affects the provision of ecosystem services. And those services have an impact on agricultural systems. In particular, since we perform an economic analysis, we are interested in the link between agrobiodiversities and productivity and resilience, economic resilience of agricultural system. And so in the first part of the project, we concentrate on the link between agrobiodiversity and land value. Example of ecosystem services that support agricultural systems are, for example, nutrient cycling, water provision, pollination. All these services support agricultural system and the provision of food, fiber, and fuel. But also, there are other services that spill over from agricultural ecosystems. The model we use is the Ricardian model. The model starts considering that the farmland value is the present value of future net revenue. And revenue depends on the output that the farmer chooses to produce, the inputs, the quantity of inputs, and also exogenous variables. In the Ricardian, the development of the Ricardian model, since if we consider a large set of farms, and assuming that all farmers can access the same set of information and have the same access to markets, we can, the Ricardian model states that eventually farmland value or difference in farmland value across farms depends only on exogenous variables. Those exogenous variables include climate variables, usually, geographic and soil characteristic, and socio-economic variables. So in our model specification, first of all, it's important to say that with respect to previous contributions, we consider separately two components of farmland value. So we consider the value of biological assets, that is mainly the value of permanent crops, and the value of agricultural land. Also in our model specification, we apply a semi-log model. So we take the natural log of the dependent variable. And also, as is usually the assumption made in the Ricardian model, we assume a non-linear relationship between the exogenous variables temperature and precipitation and the log of biological assets or agricultural land. So we estimate separately these two components. And temperature precipitation. The geographic soil characteristics are altitude and sand bulk, available water content, clay and coarse. And socioeconomical variable are variable that concern the farm directly, like the share of rented area, the agricultural used area, the subsidies, and but also it includes variable that relate to the location where the farm is located. And these are, for example, the population density and the share of road, port, and airport in a we choose in 5 kilometer buffer. In this way, this is a proxy of the accessibility to market. And also we include in the analysis, of course, the Agrobiodiversity Index. We considered several indices, at least at the beginning of our analysis, and so we include the richness density index. This index normalizes the number, for example, of land cover types, considering also the total agricultural land area. Then we have the Shannon and the Gini-Simpson, the Shannon index and the Gini diversity index. These are the most used indices in when is considered biodiversity. The difference between the two is that Shannon diversity index weights more the richness and also the rare, the less common, in our case, land cover. Instead, the Gini diversity index value more or weight more the dominance and the evenness component of diversity. So both consider richness and evenness, but weight the two differently. We also consider the Shannon evenness index in our analysis and the Simpson evenness index. The data, we concentrate on Southern Europe, so we only consider the Greece, France, Italy, Portugal, and Spain. The source of data for farms are from FADN. The climate variable, the climate normals were determined using the data from Copernicus, and Corinne land cover is the source for land cover and to determine the agrobiodiversity indices, and the soil characteristic, the source is the SDAC. So the Ricardian analysis, the first, the results of the estimates. we compare consider separately and compare the results of biological assets and agricultural land. And we find that results are mostly in line with the previous contributions. So, for example, if elevation is I can say previous contribution on Ricardian analysis negatively has a negative impact on the land value. Sand, bulk, and clay and coarse are usually also assumed to have a negative impact. We see that there is some difference between the biological assets and agricultural land. The other variable, the socioeconomic variable, instead show a very similar impact between, or very similar estimates between the two dependent variables. We see that population density, road area ratio, port, airport, all have a positive impact on land value. This is consistent with the previous results, and show that the accessibility or the vicinance to markets has a positive impact on revenues and therefore on land value. As to the the impact of climate normals, we consider seasonal precipitation and temperature, and we find that they are all significant, highly significant, and also the result confirm the existence of a non-linear relationship between land value and climate normals. So we find that we concentrate on precipitation, we find that land, biological assets or agricultural land have, so autumn precipitation is convex, okay, that farmland value is convex in autumn precipitation, winter precipitation, and summer precipitation, and convex with respect to spring, concave with respect to spring precipitation. And as to temperature, also we find that farmland value is convex with respect to autumn temperature and spring temperature, and concave with respect to winter and summer temperature. Also, these results are in line with previous, consistent with previous contribution. And of course, yes, also to be consider the turning point, that is when the, for example, for autumn precipitation, when the land value start to increase with respect to autumn precipitation. Finally, the last part of is the one that we are more interested in, concern the biodiversity, agrobiodiversity, the impact of agrobiodiversity index. Okay, the analysis was performed at landscape level, that is considering agrobiodiversity at landscape level, and at farm level. And also we assessed different regression. So one regression for each index. In this way, we want to avoid to have that effect between the index. So we the first until this moment, we prefer to consider to assess the value of each, the impact of each index separately from the other index. So indices. So surprisingly, we found differences between the impacts of agrobiodiversity on biological assets and agricultural land. This difference emerged when we analyzed the impact of agrobiodiversity at landscape level. And we see that overall we can say that agrobiodiversity has a positive impact on the value of biological assets, but a negative impact on the value of agricultural land. So if we try to find an explanation referring to agroecology literature, what we can say is that ecosystem services providing in the landscape where the farm is located spill over positively on biological assets. Instead, they are more disservices, so they have a negative impact when considering agricultural land. Of course, since this is an economic analysis, we measure land in economic terms, there are probably also other motivation related more to the economic sphere. And we are, at the moment, we are trying also to motivate with the results looking to the economic sides. Okay. Instead, when we move to the impact of agrobiodiversity at farm level, that is, we concentrate on index of agrobiodiversity within the farm and not in the landscape of the farm. We see that the impacts on biological assets and agricultural land is as the same sign, even if sometimes they differ in their magnitude. When we consider instead the agrobiodiversity index based on the number of crops grown within a farm, we see surprisingly that only richness has a positive impact on biological assets. Instead, the two indices of biodiversity, the Shannon and the Simpson, have a negative impact. This is probably due to a negative impact of evenness on biological assets. So we are already at the conclusions. We have estimated the Ricardian model separately for two components of farmland value, the biological assets and the agricultural land. And the results show that the estimated coefficients of most of the variables do not display substantial differences across farmland value components. However, the impact of biodiversity at landscape level is different. The impact on biological assets is positive, and the impact on agricultural land is negative. In addition, agrobiodiversity evenness is not significant for biological assets. At farm level, the analysis that I've shown, that is still preliminary, show that both magnitude and sign of impact are mostly similar across farmland value components, and the difference may be dependent on different impacts of agrobiodiversity evenness. Okay, thank you.
Okay, thank you. Thank you.
It's been quite fast.
No, that's fine. So perhaps you can say, given that we have 2 minutes, you can say that I mean, some extension of the database and analysis that you are performing.
This is already the.
This is the new one.
Yes.
Already. Very good.
It's been performed in a rush. I mean, that's because the data were delivered only a few weeks ago, but I think that the results are completely different with respect to the previous data, so I didn't want to show the previous results. Okay. These are already the new outcomes of the model.
Okay, so thank you for the presentation. I found it quite interesting. I have a question. A very first question. So if you can show the result of the initial regression. So I was wondering why yes, this one was not clear to me, or the interpretation between the positive relation across say population density, road, port, airport, and the biological assets. That was not very, I mean, airport is not significant, but road and port,
okay, no, because
if you had an interpretation.
Now, this relates to the accessibility, and so the price of if the farm is far away from road or port, or in an area that is not very populated. Of course, the cost of taking for example, the crops to the market is higher than if you are closer. So this is quite a standard results in the literature, that this has a positive impact on cost, transport, for example, the cost of reaching the market, and so it increased the revenue.
No, yes, because I was. It was intuitive to me for in terms of agricultural land. It was less intuitive in terms of biological assets, but that's my, my point. But
I thought I mean I can thank you for question, and I interpret this as the cost of accessing the markets, and
okay, so
it's
it works both for the agricultural land value and for the biological assets, you say.
Yeah, because it's the cost of taking yields to the markets, for example. So agricultural land is mainly related to non-permanent crops, and biological assets relates mainly to the permanent crops, but in any case you have, in both cases you have yields, and so I interpret this as the reduced cost of taking yields to the markets.
Okay, so I have other questions, but I will leave the floor for other potential question from our audience. And so if there are no questions, I will raise mine, but I mean, I will stop here to leave the possibility to others.
There is Denisa.
Yes.
Okay, Denisa. Hello, Leah. My name is Denisa.
Hi.
We don't know each other personally. I'm a senior.
I don't see you, but
that's okay. Do you want me to switch on the camera, or it would be okay if you don't see me? So
it's okay. Don't worry.
Okay. So I have a question. I have a couple of questions. I think that 5 or 6. But first, you said something about the productivity.
Yes.
Where exactly is the productivity in the Ricardian framework?
Okay, the productivity is embodied in the, of course, in the land value. If you think that the value is the average revenue, so net revenue. So the flow or net revenues are a function, of course, of the productivity of land, and this and then value will be also a function of the productivity of land. I don't know if
do you consider some agricultural inputs and outputs?
No. The Ricardian model consider only the impact of exogenous variables, and so the exogenous variable are only like climate considered in the model, but the land value is dependent on the productivity of land.
Okay, I have a couple of more questions, but I'm gonna leave it for now and give the floor to someone else and come back later, if I may.
Yes, of course, if there are other questions.
Hi. Hello.
Hello.
Can you hear me?
Yes.
Okay. My name is Elisa. I'm working with CGEs on the Water, Food, Energy Nexus. And I was thinking, so you're using indexes of diversity, let's say biological diversity. Did you thought, or could it be possible to fix some specific composition? I'm thinking of, because it like assigning specific land or specific composition of crops could improve the productivity. So fixing type of crops could be, I mean, there could be similar crops that could be different within each other, but not bring the increased productivity you're searching for. I'm thinking about the effect of mangroves that stabilize the land. So even if it's not productive, maybe, but it increased the productivity of other crops later, or crops that can resalign or improve the nutrient level of the land. So I'm just thinking if you have, besides the diversity per se, if you can fix some specific component of the crops, or if you thought about it, or if you want to do that, or if it's already in the biological asset component.
Okay, no, okay, we, at this point of the analysis, we haven't thought about refining the model. So what you refer about is interesting, because of course the interaction among different crops is not independent on the kind of crops. But at the moment, we have not included this refinement in the analysis. As to instead particular ecosystems that can affect productivity and so land value, we are thinking to include in the analysis and to assess the impact of different land use, including also semi-natural and natural area. So the next step is to assess, for example, if the impact of a riparian zone on land value. So we have information about which kind of land cover are in the 5 kilometer buffer of the farm. And so we decided to assess also the impact of natural areas. At the moment, all the indices of biodiversity are based on agricultural use of land. The next step will be to assess the impact of forests, for example, or riparian zone or wetlands.
Thank you.
You're welcome.
Okay, other questions? I have, before letting Denise, I think that she can raise her other questions. I have another question that is, I mean, basically 2 questions. First, what really changes when you move from the landscape to the farm level, basically, because results are very different. I think it is important to explain the difference across the 2 cases, because this is one of your main results. And secondly, the point is then how can you use these results? Because could you also test if there are different behaviors across different regions? Because I don't know how extended is your database, because I don't know if, for instance, you could also try to diversify your results according to somehow, perhaps agroecological zones is too much, but at least, let's say, areas where there are different environmental conditions, let's say more arid and more and less arid, so with more or less precipitation, water availability. So I was wondering whether it is possible to also study this kind of differentiation. So first question, difference between what really happens at the landscape value and level and farm level, and then whether or not it is possible to study particularly differentiated behavior across areas.
Okay, so if I move to the results of the Ricardian analysis, of course, at the moment it's challenging to provide reasonable explanations of the impact of different impacts on biological assets and agricultural land and landscape level. Because we see that at farm level, diversity at farm level has either a positive impact in most cases, or the difference arises because even as a negative, very probably even as a negative impact on biological assets. So of course it's interesting results, but also it complicates the what can be suggested at policy level, for example, for land use conservation or agrobiodiversity conservation around the farm, because we have the two opposite effects. So on one hand, agrobiodiversity is good to permanent crops, but it seems to have a negative effect on other crops. So this is the the answer is still a work in progress. As to the other question, I have run the model, estimate the model separately for each country, so some differences arise considering separately the countries, but the positive effect at landscape on biological assets is true for all countries and is even stronger. In some countries, we also have a positive impact on agricultural land. So we also need to work on this. And I was also thinking to analyze data considering different agroecological zone, or in any case, to try to create a subsample of farm that have more similar condition, like as to, for example, temperature or precipitation. So this also is still a work in progress. So is there any other question?
Yes, I have a couple of more questions. How exactly is it estimated?
Can you repeat, please? I couldn't hear you.
What is the econometric model that you use? Is this fixed effects?
Yes, it's a cross-section model because we couldn't have a panel. So we were constrained to use a cross-section model.
Is there any analytics on the residuals?
What do you mean?
Do you have any model performance slides here, or do you only have
the fit, like the
residuals distributions?
Okay, I analyzed the residuals but I mean, at the moment, I have no result to show, but I performed some. Basically, I mean, at this point, I was interested in determining if the relationship between agrobiodiversity and land value was linear or not. So I looked at the residual for the agrobiodiversity variables, and only one case, but I didn't include these results. At the moment, I found a nonlinear relationship.
Okay, why exactly am I asking, Kent? When you say cross-sectional model, you mean ordinary least squares, right? OLS.
Yes.
Okay. The problem is, of course, so why exactly am I asking? If it's not a fixed effect, maybe you have something else like outside of it, like the country, that does influence. If it's fixed effects, then the regression takes out the median value for a specific country. When you also have a cross-sectional data set, maybe there is additional things that are influencing your outcome that are now in your error term. And when it's in the error term, maybe then your estimates are not. I can write you if you want after that.
Yes.
Kind of.
Yes. Sorry, I didn't show, but I consider fixed effect for each country. So I introduced the dummy for each country. This has been done. I didn't show this because I thought it was not relevant to the, but the model include a dummy for each country.
Okay,
So
I assume that we'll see a draft of this thing at some point, right? I would be very interested.
Yes, I'm working on. I have a draft. No, I was thinking to, in some way, maybe to capture the. Since I have a different effect across countries, I was thinking maybe to run a model. I don't remember now the kind of model, I'm sorry, but that account for this, that allow to account for difference in the impact of agrobiodiversity across countries. I think maybe it's the mixed model, linear model. I was thinking to apply a mixed linear model in a way that I can estimate and in a way that I can account for a difference across countries in the value of agrobiodiversity.
And also you said that you estimated for the both elements separately. Is this correct?
Yeah. Yes. Each index has been included once only as separately because at the moment at the beginning I want to avoid to have interaction. I will move after to see if there is any interaction between the different level of analysis, landscape and farm level. So it can well be that the agrobiodiversity at landscape level interact. There is a kind of interaction with the agrobiodiversity at farm level. Also, the agrobiodiversity, at farm level is endogenous, actually it's in an endogenous variable. So one direction of the analysis probably will consider also this.
And okay, but this is actually a model that works, you know, with farm value. How do you deal then in the regression with omitted variable bias if you have OLS?
Yes, this is a problem of cross-section analysis, and probably if we account for like, I mean, in the past I made a similar analysis. It was less, biodiversity was included, but it was a case study of Sicily, the region I'm from. And we included endogenous variables and spatial effects to deal with omitted variables. It was a small sample. It's probably that we will also develop this kind of analysis for all this huger sample.
Okay, thank you. I'm looking forward to reading the draft.
Thank you very much.
Okay, so I think for the sake of time, we should conclude here. And thank you very much, Lea, for the presentation and the participant to the webinar. And of course, we expect to have another one where we get the presentation of the results of the development of the work. So we can already start to have in mind that there will be a follow-up to this seminar, perhaps to present the more the extension of the work and the more definitive results from your Marie Curie. Okay, So thank you and bye-bye.
Okay.